Let's give this a try. Sample exam number 1. Here's the first problem. Is this a relationship? 7 goes to 9, 8 goes to 9, and 9 goes to 10. You know what? I'm going to say yes, because 7 goes only to 9, 8 goes only to 9, and 9 goes only to 10. None of these inputs go to more than one output. Now, what about here in number 2? Let's look at number 2 here. Is this relationship a function? Well, 2 goes to 5, but 2 also goes to 6. So right away, we can say no, because 2 goes to 5, and it goes to 6. So one input value, 2, goes to more than one output value. So it's a relation, but not a function. And in number 3 here, 22 goes only to 17, 12 goes only to 16, and 19 goes only to 17. Now, it turns out that the 22 and the 19 both go to 17, but that's okay, right? Because each input goes to only one output. It's not like the 22 is going to 2 different places. So let's say yes, this is a function. And here in number 4, can we write the domain using set notation? Well, the domain, this is a set of x values. So our domain is going to be the set of 6, 7, 8, and 9. There it goes. We're just asked for the domain here, so we're not asked for the range. But if we were asked for the range, that would be 10, 11, 12, and 13. Now, here in problem number 5, we are asked to get the domain and the range of this relationship right here. So the domain, this is going to be the x values. These are the horizontals. So it looks to me like the horizontals are going from what do we have here? Negative 1, 2, 3, 4, 5, negative 5, and negative 5 is included, up to 1, 2, 3, 4, positive 5, but positive 5 is not included. So maybe we can write this domain here. I'll just say D. The domain goes from, all right, square bracket, because negative 5 is included on that x, and to positive 5, but open parentheses here because this 5 is not included on the x. Now, for the range, these are going to be the y values. So the y values go from low to high. Now, it looks like they go from negative 3 all the way to positive 3, and everything's included, right? No matter where you put your pencil on this y-axis, you can find part of the curve. Now, even though this is open, it happens to be closed on that side, so we really do get that value of 0. So let's write this range as negative 3 to positive 3, and we will use square brackets because both the negative 3 and the positive 3 are included. And now what we want to do here in number 6 is to evaluate this function when x is negative 2. So here's how we've been doing this. We will write f, and everywhere we see an x, we'll leave an open parentheses, something squared minus 3 times something plus a 5. And now we can go back in and fill in those parentheses. So now we're going to have, I'll just do it here, put in negative 2, and that's going to be negative 2 squared minus 3 times negative 2, and then plus 5. This will give us 4. Negative 3 times negative 2 is plus 6, and plus 5. Looks like 10 and 5 is 15. So we're going to claim now that f of negative 2 is 15. And we could say this. When the input is negative 2, the output is 15.